This video is to use your TI-83s to graph your exponential and log functions. If I was going to graph the function f of x is equal to 3 power x, I would simply go ahead and turn on the calculator. Click on y is equal to 3 to the power x and graph. And if I want to look at the table, second, graph. And that would give me the table all the way from negative to the positive side. Now let's go ahead and graph the function 1 over 3 power x. So parentheses 1 over 3 to the power x. Graph. And if I want to look at the table, second, and graph. Negative 3 is negative 27, negative 2 is negative 9, negative 1, when x is negative 1, y is 3. If I want to go ahead and graph 2 power x plus 1 from the function 2 power x, it's a transformation. So if I want to go ahead and see the transformations, I would go ahead and graph both the functions first. So in this function, I would be 2 power x, that's my main function f of x, and the g of x would be 2 to the power. Every time you see a plus or minus sign with the power, it has to be in parentheses. Plus 1, close parentheses, and graph. That's my first function 2 power x, and that's the next function 2 power x plus 1. So I see that there is a horizontal shift of 1 unit to the left. And if you want to go ahead and take a look at your coordinates, then this is what it's going to be. When x is 0, the first graph is 1 and the second graph is 2. When x is 1, the first graph f of x is 2 and g of x is 4. So you see that there is a horizontal shift of 1 unit to the left. If I want to go ahead and graph the function f of x is equal to 2 power x and the transformation g of x is 2 power x minus 1. So let me go ahead and graph both the function first. 2 to the power x is my function f of x. 2 to the power x minus 1 is my next function. When I graph it, that is my first function 2 power x, that's the next function 2 power x minus 1. So I see that there is a transformation of 1 unit. There's a vertical shift of 1 unit down. If I want to go ahead and look at the coordinates, then these are the coordinates. Negative 3, 0, 1. When x is 0, the first graph is 1, the next graph is 0. When x is 1, the graph 2 power x is 2. 2 power x minus 1 is 1. So you see that there is a shift of 1 unit down. And when I look at the graph, I notice that there are 2 asymptotes in this function. So when I go ahead, there are 2 ways of finding the asymptotes. You can find your asymptotes from your graph. That is when x, let me just move to the x part here. When x is going to infinity, negative infinity, when x is going to negative infinity, I see that the first graph 2 power x is going to 0 and the second graph is going to negative 1, right? So you see when x is going to negative infinity here, the first graph is going to 0, the second graph is going to negative 1. So if I want to go back and look at the graphs, the horizontal asymptote for the first graph 2 power x is y is equal to 0. The horizontal asymptote for the second graph is y is equal to negative 1. Now let me go ahead and graph the function y is equal to negative 1 and you will see the asymptote. That is the asymptote for the second function 2 power x minus 1. That's one way of looking at it from the graph, or you can simply look at it from your table. When x is going to negative infinity, you see that the y is going to negative 1, negative 1, negative 1. So for exponential functions, you would have a horizontal asymptote. Finding logs to a different base. So how do I evaluate log 1 over 25 to the base 5? It would be log 1 over 125 divided by log 5, and that would be negative 3. So in the other words, you're asking yourself, to what power should you raise your 5 to give you 125? If I was trying to find log 6 to the base 36, I would simply plug in log 6 divided by log 36. That would be 0.5. If I want to change this to a fraction, math, the first one fraction, so enter 1, enter. That would be a half. If I want to find log 16 to the base 4, log 16, close parentheses, divided by log 4, enter. If I have to find log 7 power 8 to the base 7, log 7 to the power 8, close parentheses, divided by log 7, and that would be 8. Graphing a log function, so I'm just going to go ahead and plug y is equal to, if you want to graph a log function, you're simply going to go ahead log x and graph. If you want to graph log x plus 5, I'm going to clear this one, log of x plus 5 and graph. If I'm trying to find the domain of log x minus 5 to the base 4, I would simply go ahead and graph log x minus 5. Even though it's to the base 10, the graph would look the same, so I'm going to go ahead and graph it. And I see that the graph starts from 5 going all the way up to infinity. So the domain would be 5 to infinity. If I have to find the domain of log 2 minus x, I would simply click log 2 minus x, close parentheses, and graph. And I see that my graph starts from 2 going all the way up to infinity. Or I could simply click second and graph, that would give me the table. And I would see that my graph starts at, I'm going the wrong direction. Let me just go all the way to the bottom here. My graph starts at 2, see, from 2, so 2 is my vertical asymptote. 2 all the way to negative infinity. That's another way of looking at the domain. And in this case, x is equal to positive 2 is my vertical asymptote, so I don't have values beyond 2. Another way of solving your exponential functions is I would simply go ahead and graph the function 5 to the power, parentheses, 3x minus 6, and graph it. And I would look at the table, and I am looking at the value of x where y is equal to 125. So I'm looking at x is equal to 3. When x is equal to 3, the value of y becomes 125. So the solution here is 3. That's one way of doing it if they are perfect integers, but if they're not, sometimes it's going to be hard, so you go ahead and change them to the same base. Now let's go ahead and try if we can do it with the other one. So here I'm going to clear. We're trying to solve 4 to the power 2x minus 1 is equal to 64. So I'm going to plug in my function 4 to the power, parentheses, 2x minus 1, close parentheses. And remember, I'm trying to look for the value of x where y is 64. So instead of graphing it, I'm simply going to go ahead and look at the table. Second and graph would give me the table. So the value of x where y is 64 is 2. So the solution here is 2. I could go ahead and always check if I'm on the right track or no. Second, quit. So I'm saying the x is 2, so 4 to the power 2. I'm replacing x as 2 in this equation, times 2 minus 1. Bingo, and that is 64. So your solution is correct.